The commutator subgroup plays a very important role in group theory, and in this video, well, I'm going to define what's a commutator, what's a commutator subgroup, and then I'm going to prove one of the very important properties of it, which is that it is a normal subgroup. If G is a group and X and Y are elements of the group, then a commutator, which is usually denoted in brackets X, Y, it's the element X times Y times X inverse times Y inverse. And notice that if X and Y commute, the commutator is just the identity element. And then the commutator subgroup is the subgroup generated by all commutator elements. It's not the set of all commutators, that's in general not a subgroup, but it's the subgroup generated by all commutators. So every element of the commutator subgroup is a product of commutator elements. So notice in particular that if the commutator subgroup is trivial, then every commutator element is trivial, and therefore every pair of elements commute. So therefore G is abelian. And in this video, we're going to see that the commutator subgroup is normal in the group G. How are we going to prove this? I'm going to start by showing what happens when I conjugate one single commutator element. So let G be in G, let X and Y be elements of the group G, and let's conjugate one commutator element. So I get this, and let's see what happens. When I conjugate one commutator, what I'm going to do is introduce between X and Y, between Y and X inverse, and in here also, I'm going to multiply by G times G inverse, which is the identity, to get this very long expression. But then I'm going to regroup, so this is G times X G inverse, this over here is G times Y G inverse, and then this part over here, it turns out that G times X inverse times G inverse is G times X times G inverse inverse, because remember that the inverse of a product is the product of the inverses in reverse order. What I've proved is that the conjugate of a commutator is a commutator of conjugates, but in particular, it's a commutator, so it's in the commutator subgroup. And now I have to do the same thing, but for an arbitrary element of the commutator subgroup. And an arbitrary element of the commutator subgroup is a product of commutators. And now we can see what happens when I do the conjugate of an arbitrary commutator element. It will be the conjugate of a product of commutators, and introducing G times G inverse between every product of two commutators, we can see that that is a product of conjugates of commutator elements. And therefore, because we have shown that the conjugate of a commutator element is the commutator of conjugates, that means that this conjugate is also a product of commutator elements, and therefore it's in the commutator subgroup. This shows that every conjugate of the commutator subgroup is contained in the commutator subgroup. And that is an equivalent condition to the subgroup being normal, and therefore we have proved that the commutator subgroup is normal in G, as we wanted to prove.